Hello everyone, and welcome to the Modern Java course. HTTP requests in Java have always been a pain. The URL class and its related classes predated REST and are unintuitive. Thankfully, JDK 11 introduced the new HttpClient API, which makes REST calls trivial by comparison. Before I proceed, as usual, the code for this and the other videos in this series is available on my GitHub page, so check out this project, start, and follow me on GitHub. There are many ways to make an HTTP request in Java, and they all have their faults. I mentioned the URL class before, but there were some interim solutions such as Apache Commons that picked up the slack. HttpClient is a major step forward in that regard. It took the good ideas from the community and converted them to a unified simple API. Unfortunately, because the Apache HttpClient has the same name, searching for this is somewhat confusing. HttpClient is an immutable API that uses fluid syntax to perform a request. It has two versions of the API, synchronous and asynchronous. The synchronous API looks like this. As you can see, it uses a builder pattern to define the request. This is a bit awkward sometimes as the API becomes somewhat convoluted with two builders for a simple request. However, most of these can be reused, and at that point, the code can be made simpler. Let's review. We first need an HttpClient instance. Here we can define the settings of the communication protocol. We can override authentication, timeouts, cookies, cookie handling, redirect, SSL, and more. We don't need to allocate more of these. We can reuse that instance and invoke that code only once. We can also reuse the request instance, but it's per request sent. In this case, the request is a GET request for a specific URI. If we will keep polling we can reuse the request, but we usually wouldn't want to do that. The request accepts the method that we want to connect to, the URI and the details for the request. To make things interesting, we can copy the request builder and create a slightly modified request based on a template. The interesting bit is the response that you can see here. We can define any response handler out of a few ready-made options or a custom option of our own. Also notice that the client send is the synchronous version of this API. By replacing this with send async, we can perform this call asynchronously. This will return a completable future, which we can use to get the actual response. Asynchronous operations can run on the default executor, or we can define our own executor in the HttpClient builder. This lets us define a pool of networking threads, a very powerful feature. Here's a sample post request based on the sample from the Java doc. There are several interesting concepts here. Notice the post method is passed to the request. Methods that accept body also need a body publisher. This is an interface that lets a client provide data. There are several ready-made publishers within the body publishers class. They can work with files, streams, byte arrays, and more. The send async method sends the request we created above and uses the body handler to handle the transformation of the request. In this case, the output is processed to a string, which we redirect to the print method and send it to the console. Up until now, we saw features that existed in the JDK before in one form or another. Sure, we didn't have an asynchronous API, but the feature of connection over HTTP or HTTPS wasn't new. HttpClient adds new support for WebSockets, which existed in third-party libraries but not in the JVM. WebSockets are TCP sockets created over the HTTP or HTTPS request. Once the request handshake is made, the socket from the connection is passed to the application and it can write or read arbitrary data as if it was a regular socket. This has many advantages, but that's a distraction. We can open a WebSocket with this code. It connects to the given URL and calls us back on the listener. This seems simple, but it skips a major part, the listener. This is the sample listener from the WebSocket documentation. Notice that the interface includes several callback methods such as onClose, onBinary, onError, onOpen, and more. They all have default implementations, which lets us implement the interface without overriding all of its methods. This code seems complicated with all its different parts. This is because WebSockets are almost like regular sockets. A piece of information you need might be broken to multiple packets, and we will need to reconstitute them to extract the meaning. Let's dig deeper to understand this code. We have two fields. We use parts to collect all the messages we receive into a single message, but the accumulated message completable future is the part that's harder to grasp. We need it for the return value of the method. We could return null instead, which would mean we received the complete set of messages implicitly. Why do we need this? The key is how. Every time we get an event from the WebSocket, we get the data. It seems like pretty standard code, but notice this isn't a string. It's a car sequence. When we have a high throughput connection, we might read data very fast. Creating a new string for every packet might be very slow. A faster solution would be to pass the internal buffer used by the socket as a sequence. This saves on allocation and garbage collection. But the downside is if we pass the internal buffer, then when will the WebSocket be able to reuse that buffer? When we invoke the completion that we previously returned, it means that we no longer need this buffer. If we return null from the method, the value held by the message variable could become invalid. This isn't a problem if our code always copied the value of the message to a variable by using a method like toString. We could just return null and significantly simplify the code. This sort of code makes sense only for very high volume connections. Adding to a list and creating new completable futures also have an overhead, so it might not be as valuable. The HttpClient API is pretty interesting and worth taking our time to experiment with. It still suffers from some verbosity due to its builder patterns, but its immutable and modern design are a breath of fresh air over the old URL code. Next week, we'll talk about GraalVM and its native image support. Follow through the videos to check out the full course. If you have any questions, please use the comment section. Thank you.